So we've been working on solving systems of equations with elimination. And I think a lot of you really picked up on that method quickly, and it was rather easy if they lined up and if your coefficients were either the same or opposites. But what happens if you don't have common coefficients, same coefficients or opposite coefficients? An example in this problem. See, there's a 1x and a 2x. They're not the same and they're not opposites. That's a 3 and a -7. They're not opposites. They're not the same. Well, if you like elimination, there is still a way to make it so that you can use elimination. Remember, you can do anything you want to an equation as long as you do the same thing to both sides. So if you get a situation like this where they're lined up, but there's not a common coefficient, then simply look to see if you can fix one of them so that you can make them the same. So what you want to do, here's an x and here's a 2x. Well, how could I make that x into a 2x? What could I don't know, multiply it by? Well, if I could multiply it by 2, right, that would turn that into a 2x, and then they would match. You're allowed to do that. So if there are no common coefficients, take one of your equations, or maybe both of the equations, by a number to make the coefficients, the x numbers or the y numbers, okay, so for number 1, as I said, if I multiplied this top equation by 2, so times 2 times 2 times 2. Now you can't just multiply the x term. You got to multiply the whole equation. Remember, what you do to one side of the equation, you have to do to the other. And you can do anything you want to an equation as long as you do it to both sides. So I'm going to take this second equation, and I'm going to multiply everything times 2. So instead of x, it becomes 2x, and instead of 3y, it becomes 6y, and instead of 6, it becomes 12. And now this second equation, I don't have to do anything at all to it. And if you notice now, I have coefficients that are the same, and if they are the same, then I can subtract, and the 2x's are eliminated, and then I need to do the y numbers. So be careful. This is 6 take away -7. 6 take away -7 is 13. And here for the constant, 12 take away -1. 12 minus -1 is 12 plus 1, which would be 13. And then when you divide both sides by 13, you get y equals 1. So now we have our y number. And the next step is exactly the same. Pick an equation. You can choose one of these, or you can choose the one you changed it into. It doesn't matter. If I'm looking at this, I'm probably looking at the first equation that says x plus 3y equals 6. And since I know my y number is 1, I'm going to substitute it in right there. So this becomes, instead of 3 times y, it's 3 times 1. 3 times 1 is 3. Simply take away 3 from both sides, and you get x equals 3. So you can still use elimination even if the coefficients are not the same or opposite. You just want to you need to fix one of the equations. So for example, let's look at number 4. X plus y equals -3 and 5x minus 2y equals -50. They're lined up, but the numbers don't match, or they're not opposites. So I've got, in this particular problem, I've got 2 things I could do. I hope you see this. I can multiply the top equation by 5 to make these 5x's the same, or I can multiply the top equation by 2 to make that a 2y, and that's a -2y. And that's what I'm going to choose to do. You can do either one. I'm going to multiply the top equation by 2. So instead of x, it becomes 2x. Instead of y, it becomes 2y. And instead of -3 times 2 is -6. And the second equation I'm going to keep just like it is. And now I have opposites, +2 and -2. and I can eliminate those if I add. So 2 and 5 make 7. Negative 6 plus negative 50 make negative 56. Divide both sides by 7, and you get x is equal to negative 8. I'm going to go back to one of my equations. I'm going to choose the one that looks the smallest, which is x plus y equals negative 3, my first equation. And I'm going to plug a negative 8 in for x. Solving that by adding 8 to both sides, I get y is equal to 5. Okay, so analyze your equation. So on number 3, I'm not going to work it, but I know what I would do. I would multiply the top equation by 4 to make that a negative 4y, and then that would match up with the positive 4y. And then I would go from there. So let's see a problem like number 8. If I look at number 8, always look at the smaller number, a 3. I can't multiply that times anything to turn that into a 5. So that doesn't help me. For the y numbers, the smaller one is a 3. I can't multiply that times anything to get me a 4. So in this case, instead of multiplying one of them by a number, which is what I usually can do, in this case, I need to multiply both of the equations by 2 different numbers, not the same number, 2 different numbers. So an easy way to do that is look at the x numbers. I need to turn these x's into the same number. So take your first number, 3, multiply it times 5. So I'm going to multiply this equation times 5. And then I would take that second equation, and I hope you see what I'm going to do. I'm going to multiply it times 3, which means the x's would turn into 15x here, and it'd also turn into 15x here. Now I got to multiply all the way through, though. Don't forget, don't just multiply the x term. So that turns into a 15x. This turns into a 3 times 5 is 15y. And 9 times 5 is 45. The bottom equation I'm going to multiply by 3. So I'm getting 2 brand new equations. 3 times 5x is 15x. 3 times 4y is 12y. And 3 times 10 is 30. And now that I have these 2 equations, and these numbers are the same, I can eliminate those if I subtract. 15 take away 15 is 0. 15 take away 12 is 3, y, and 45 take away 30 is 15. Divide both sides by 3, you get y equals 5. Okay, I need to find the x number. You know the step. Now at this point, you can choose one of your 2 original equations. You can choose one of your 2 brand new equations. I'm going back to my originals because the numbers are smaller. And I'm probably going to choose, I don't know, I could choose either one, but I'm going to choose the first one. 3x plus 3y equals 9. And now I'm going to substitute in 5 for y. So this becomes 3x plus 3 times 5 equals 9, and I need to solve it. So 3 times 5 is 15. We're going to multiply that together. Running out of room here. I'm going to take away 15 from both sides, and that would give me 3x equals negative 6 when I take away 15. When I divide by 3, x is going to be negative 2. So you can still use elimination. Most of the time, you can simply multiply one of the equations to get them to match, like we did in number 1 and like we did in number 4. Sometimes you might need to multiply both equations, like we did in number 8. Okay? Elimination with multiplication.